Example 2 in graphing exponential functions is to graph the exponential function 1/3 to the power of x. Now, if you've been following these videos, the previous one had a function 2 to the power of x. This one has a function 1/3 to the power of x. You should see immediately that the difference between them is that this new one, 1/3 to the power of x, involves a fraction as the base. Okay, so these are both exponential functions, but they're going to behave in somewhat different manners, and that's because this number here, the 1/3, is less than 1. Okay, so let's see how that works. So we're going to do it the same way as before. We're going to make a table of values, table of x values, and then find out the corresponding y values. Okay, so our x's, we generally go from -3 up to 3, -3, -2, -1, 0, 1, 2, 3. And this time the exponential function, we'll call it y. Sometimes it's called f of x or g of x. We didn't give it any of those this time, so we'll just call it y is equal to 1/3 to the power of x. Okay, well this is going to be, we're going to fill this in now, replacing the x with whatever x value there is in a particular line. So this is going to be 1/3 to the power of -3, 1/3 to the power of -2, 1/3 to the power of -1, 1/3 to the power of 0, 1/3 to the power of 1, 1/3 to the power of 2, and 1/3 to the power of 3. So we've got this question to 1/3 to the power of -3. Okay, so we've got a fraction with a negative power. What do you do? So we've got a fraction and a negative power. How do you handle that? Well, what you do is you turn the fraction upside down. Okay, so it becomes 3 over 1. So turn the fraction upside down and make the power positive. Okay, so we turn the fraction upside down, make the power positive, and then that's 3 to the power of 3 over 1 to the power of 3. So you apply the power to the top and the bottom of the fraction separately. 3 over 3, I'm just going to give myself a little bit more room here. 3 to the power of 3 is 27, 3 by 3 by 3. 1 cubed, 1 by 1 by 1 is 1, so it's just 27. Another way of doing that, 3 over 1 is just 3. A simpler way to do it maybe would be 3 over 1 is just 3, so this becomes 3 to the power of 3, which is 27. Okay, so that's probably a simpler way to do it. Okay, so let's go back and start filling these in now. So 1/3 to the power of -3, that's one we've just done, and it's 27. Okay, it can be hard to see how that can turn into, how 1/3 to the power of -3 can turn into 27 unless you actually work it out. It's not something obvious, so you have to go through some form of working these things out and thinking them through. So 1/3 to the power of -2, if you do the same work with that, you're going to get 9. It's going to be, turn it upside down, is 3 over 1 or 3 squared. 1/3 to the power of -1, turn the fraction upside down, is 3 over 1 is just 3, and the power becomes positive, 3 to the power of 1 is just 3. Okay, now 1/3 to the power of 0. From the last example that we've done, you should know that anything to the power of 0 is just 1. 1/3 to the power of 1 is 1/3. Anything to the power of 1 is just that same thing itself. 1/3 squared. Square the top and square the bottom. 1 squared is 1. 3 squared is 9. 1/3 cubed. Square the top, or cube the top, cube the bottom. 1 cubed is 1. 3 cubed is 27. So now we've got our points. Okay, these are our points here. Points are, remember, always x, y. So that's going to be -3, 27, -2, 9, -1, 3, 0, 1, 1, 1/3, and 2, 1/9, finally 3, 1/27. Okay, so those are our points, and now we just plot those points and graph them. So hopefully this is going to work out okay for us. If I can find my cursor. Something strange is happening here. try it this way. Beg your pardon for this. Pause. Let's put something there and see if we can. Okay, and move it to where we want it. Okay, and then let's see if we can make it a little bit bigger as well. Okay, so now we have our axes. We're going to plot these points. So the first point we had was negative 3, 27. So go over to negative 3 and up to 27. So there's negative 3 and there's 27. Okay, next point negative 2, 9. Over to negative 2 up to 9 is here. Next point negative 1, 3. Over to negative 1 up to 3 is there. 0, 1. Over to 0 up to 1 is here. And then it becomes tricky. Okay, because then we're into fractions. So 1, 1/3. So here's 1, and that is 1 on the y-axis. We want to go 1/3 of the way up, right there. 2, 1/9. So let's go to 2 and up to 1/9. So imagine dividing this little space here up into 9. Okay, imagine dividing that space up into 9. You go 1/9 of the way up, be down close to that. And 3, if we remember 3 was 1 over 27. So nearly a very difficult job to draw 1 over 27. Again, if that's 1, we want to go 1/27th of the way. So imagine breaking it up into 27 different little segments, equally spaced. You'd be down really close to the y-axis, to the x-axis. Okay, so here are points coming into focus now. So those are our points, and you can see that the ones with fractions, because I zoomed in so much, they hardly show up at all. But what we're going to try and do is try and draw that, and again, on the right-hand side, this time it's tailing off, getting closer and closer to the x-axis. But this graph actually doesn't touch the x-axis. If you used more points, you'd find they never touch the x-axis. So I'm going to try and draw this. The key here, if you can manage it, is not to let your line touch the x-axis. Okay, I'm drawing it very, very slowly. And start to put a bit of bend on it at this point. And then you just hope that you're able to graph it somewhat realistically. And that's it. I've got a bit of a tail off at the end. It should be actually getting steeper at the end. So it's better if it looks somewhere like that. Okay. So there's the graph of y equals 1/3 to the power of x. Okay. Y equals 1/3 to the power of x. And this time the graph is coming down. And what that indicates is that you've got exponential decay. Okay, this is a graph of a process called exponential decay. It happens a lot in nature. It happens in radioactivity. It also happens with depreciation of assets. If you own something that loses value over time, like a car, this is the kind of graph you get if you were to graph the value of the car against the length of time you own the car. You'd have this shape of a graph. Exponential decay. Right, let's talk about domain. Domain, it can go back as far as you want it to. So domain is from negative infinity to infinity. The range, the bottom of this graph, is at the x-axis, so 0. It doesn't have any top, it keeps going up higher and higher. And the x-intercept. Okay, the x-intercept is this point here where it crosses the x-axis. That's the x-intercept. And that's the point 0, 1. So just to dwell on this thing for a little bit, this is exponential decay. Exponential growth that we saw in the previous example, we didn't call it exponential growth there, but it is termed exponential growth, is when the graph goes up in the other direction. Okay, so exponential growth, the graph behaves this way. Okay, so exponential decay is the one that's shown here in purple. Exponential growth is there. Now, if you were to ask, how could you tell the difference between them before you start? Exponential decay has a fraction raised to a power of x. Fraction, when we say fraction, can be a decimal. It's a number less than 1. Okay, a number between 0 and 1. Exponential growth happens when you have a number that's bigger than 1 raised to the power of x. Okay, so if you have a number bigger than 1 raised to the power of x, you get growth. If you have a number less than 1 raised to the power of x, you get decay. Okay, thanks again for watching.